The silent takeover begins. Look at this. What if the best coders in the world weren't human anymore? Most people believe that writing complex algorithms is something only top-tier engineers can do. But that's about to change. Because Google's AI isn't just helping us code, it's evolving entire systems on its own, and outperforming human experts in silence. In this video, I'll show you how AlphaEvolve is rewriting decades of software and breaking records mathematicians haven't touched in over 50 years. This isn't a theory, it's already running inside Google's infrastructure, saving millions and quietly shaping the future of AI. But here is the twist. This AI isn't just a smarter chatbot. This is something else entirely, Saiwai. A new breed of AI that's not learning like us. It's surviving, competing, and improving in ways that feel almost alive. Let's unpack what might be one of the most underrated and most powerful breakthroughs in AI to date. The silent breakthrough. In early 2025, DeepMind quietly unveiled AlphaEvolve, a next-generation AI agent that doesn't just generate code. It invents completely new algorithms. We're not talking about slight improvements or small patches here. We're talking about full-on, ground-up, brand-new systems that outperform anything written by hand. Think of it as survival of the fittest, but instead of evolving species, it evolves software. And it's not just sitting in a lab. AlphaEvolve is already running live across Google's infrastructure. It's embedded in major platforms like Borg, the data center scheduling system that controls Google's vast network of servers. In just one deployment, AlphaEvolve managed to recover 0.7% of Google's global compute resources. That may not sound like much, until you realize that at Google's scale, that's worth millions in energy and infrastructure savings. But how exactly does this thing work? Unlike traditional AI models that predict the next line of code, AlphaEvolve runs in a continuous loop. It generates thousands of possible solutions, tests them, keeps the best, and discards the rest over and over until it finds something better than anything humans have built before. And this is just the beginning. Next, we'll look at how this AI is writing full programs, not just snippets, and even improving the very systems used to train other AIs. That's where things start to get surreal. Smarter than your average coder. Most AI coding tools work like assistants, autocomplete on steroids. They're built to finish your sentences, hatch your functions, or write short snippets that help human developers go faster. But AlphaEvolve isn't here to assist. It's here to compete. Unlike traditional models that focus on one-liners or pre-trained routines, AlphaEvolve is evolving full programs, hundreds of lines long, with complex logic, conditional structures, loops, and deeply integrated functionality. And it's doing it with clarity. This isn't spaghetti code no one can understand. The output is clean, readable, and ready to deploy, as if written by a senior engineer who never sleeps. And what makes it especially terrifying, or brilliant depending on how you look at it, is the process behind the code. AlphaEvolve starts with an open-ended problem. Then it fires off thousands of possible answers. The bad ones get tossed immediately. The good ones? They're refined, mutated, combined. The whole thing runs in a loop, sometimes for hundreds of iterations, until the AI discovers something that simply works better. And in many cases, dramatically better. AI that improves AI. One of the most mind-bending examples of AlphaEvolve's power, it turned inward and improved the training of the very AI models that power it. At the heart of Google's most advanced language models like Gemini are massive computation pipelines. One crucial component is a matrix multiplication kernel, a low-level operation used billions of times during training. AlphaEvolve rewrote it, and with that one change, the entire process sped up. A staggering 23% boost in that specific operation led to an overall 1% decrease in total training time. 1% might sound small, but when you're dealing with models that run on fleets of TPUs for weeks, that's a massive win. We're talking less electricity, less hardware usage, and faster model development. But it didn't stop there. AlphaEvolve went deeper into the hardware itself, specifically Google's custom tensor processing units, or TPUs. These chips are already finely tuned by expert engineers, and AlphaEvolve still found a way to improve them. It rewrote part of an arithmetic circuit in Verilog, the same language chip designers use. Engineers reviewed the change, approved it, and now it's going into future TPU designs, a machine rewriting the machines we build to power our machines. Let that sink in. Coming up next, AlphaEvolve breaks a math record no one touched for over 50 years, and what that means for the future of computing. Record breaker or something bigger? In 1969, mathematician Volker Strassen achieved something extraordinary, a way to multiply two 4x4 matrices using just 49 scalar multiplications. For over 50 years, no one could do better. Not brilliant minds, not modern machines. The record held like an unbreakable wall in computational mathematics. Then Alpha Evolve showed up. Without any fanfare, it cracked the problem, generating and testing over 16,000 algorithms until it landed on one that did the same operation using just 48 multiplications, one less than Strawson's, but in high-performance computing, one step forward is massive. And it didn't just beat the record, it did it on a tougher variant involving complex valued matrices. In other words, it broke the record on hard mode. But that wasn't a fluke. This is part of a growing pattern. DeepMind ran Alpha Evolve across more than 50 mathematical challenges, everything from number theory and geometry to Fourier analysis. In 75% of cases, it matched the best-known human solutions. But in 20%, it found something better. Take the kissing number problem. A brain-bending puzzle that asks, how many spheres can simultaneously touch a central sphere without overlapping? The best-known answer in 11 dimensions was 592. Alpha Evolve found 593. Just one more, Rita. But in the math world, that's a revolution. What makes this all more astonishing is that Alpha Evolve isn't a one-trick AI. It's not trained for each specific problem, it generalizes. As long as the challenge can be expressed in code and the result can be automatically measured, it goes to work, testing, evolving, improving. Centuries of mathematical insight being matched or outpaced in days. So how does it do this? How can an AI evolve logic better than the minds who created it? Next, we peel back the curtain and explore the engine behind Alpha Evolve and why it might be the future of how we write code altogether. The evolutionary engine behind the curtain. At the core of Alpha Evolve's power is a simple but ruthless idea: evolution. Here's how it works. It all starts with a prompt, a description of the problem to be solved. That prompt might include context, failed past solutions, or even just a few hints about what the AI is aiming for. Then, Alpha Evolve goes to work, generating thousands of potential answers. But it doesn't just pick one and call it a day. Instead, every single solution is scored, automatically, based on how well it performs. Speed, accuracy, memory usage, energy efficiency. Every candidate gets tested, evaluated, and ranked. The worst are thrown out immediately, the best rise to the top. Like this video? Then hit like and subscribe to help us with the algorithm and show the video to even more people. Then comes the twist. The top performers are used to breed the next generation. Alpha Evolve uses the best parts of the top algorithms and mutates them into new variants. Slightly different versions with the potential to outperform their predecessors. This process repeats round after round, just like biological evolution. Only here, survival of the fittest isn't about life, it's about logic. If the results stop improving, the system knows how to shake things up. It can inject older solutions from earlier generations to prevent getting stuck, or throw in wild variations to explore unexpected directions. And it all happens at machine speed. What would take a team of elite engineers weeks of trial and error now happens in hours. No burnout, no bottlenecks. Just relentless automated iteration. But that's just the framework. What really makes Alpha Evolve dangerous and brilliant is the twin engine system powering those generations. Two brains are better than one: Gemini Flash and Gemini Pro. Alpha Evolve is powered by not one but two versions of Google's Gemini language model, each with a different role. The first is Gemini Flash. It's the fast, lightweight version. Think of it as the AI's rapid-fire idea generator. When a new problem is introduced, Flash goes wild, pumping out hundreds, even thousands of code variations in minutes. It's the front line, the high-volume explorer scanning the terrain. Then there's Gemini Pro, heavier, slower, but smarter. When Flash starts hitting dead ends, when the evolutionary process stalls or starts recycling the same ideas, Gemini Pro steps in. It brings more depth, more nuance, and more structured logic. It's like a specialist being called in to rescue a failing mission. And because Pro can handle more abstract or complex reasoning, it often introduces entire new strategies that Flash simply can't think of. Together, they create a two-layered brain. One that moves fast and explores wide, the other that thinks deeper and sees what the fast one misses. And with both working in a loop, guided by automated evaluators, Alpha Evolve can push through plateaus, avoid dead ends, and reach solutions humans would never even attempt. But what exactly are these evaluators judging? And why is automation such a critical piece of the puzzle? Next, we'll look at how the system knows what's better, and why that evaluation process is what makes Alpha Evolve truly self-sufficient. Here's the next part of the script, diving into the heart of how Alpha Evolve judges its own creations and why that makes it so different from traditional programming. We'll also explore its current limitations, giving the audience a balanced and realistic view before wrapping up with what's coming next. Judging the code, no humans needed. One of the most surprising parts of Alpha Evolve isn't how it generates solutions, it's how it evaluates them. Because there's no team of engineers combing through thousands of lines of code, deciding what's good and what's not. That would take forever. Instead, Alpha Evolve relies on automated evaluators, custom-built systems designed to score every program it creates. These evaluators don't care how clever the code looks, they care about results. They ask questions like, does the algorithm solve the problem correctly? Is it faster than the current best method? Does it use less memory? Is the output reliable under different inputs? And the answers come fast. Let's say Alpha Evolve is trying to multiply two matrices. The evaluator runs each algorithm through a series of tests, times the results, checks the output, and scores it instantly. No guesswork, no opinions. Just raw performance data. The top performers go forward, the rest are discarded. This closed feedback loop is what makes Alpha Evolve so relentless. There's no waiting on human reviews, no bottlenecks in quality control. The system can run through thousands of generations, scoring and evolving every round, all without ever needing a break. But this strength is also a limitation. Alpha Evolve can only operate in domains where success can be measured, where there's a clear objective metric: speed, accuracy, efficiency. It thrives in math, chip design, AI training, and optimization tasks. But ask it to interpret the emotional tone of a poem or judge the quality of a painting? It can't, because if a solution can't be scored objectively, the loop breaks. The system doesn't know what's better, so it can't evolve. That's why creative writing, abstract reasoning, and subjective science still remain mostly out of reach, at least for now. Where this is headed next. Despite those boundaries, the potential is enormous, and DeepMind knows it. Right now, Alpha Evolve is already saving millions in compute costs, rewriting low-level AI training systems, and editing chip designs. But that's just the beginning. Next, DeepMind is aiming Alpha Evolve at entirely new fields: material science, sustainability, even drug discovery. Any problem that can be expressed in code and judged with a measurable outcome is now on the table. They're also building a user interface to make Alpha Evolve more accessible. A version for researchers is already in development, and DeepMind has hinted at a broader rollout in the future. Imagine a world where scientists, engineers, or even startup teams can plug into this evolutionary engine and instantly get solutions that outperform decades of human work. But here's the deeper shift. Alpha Evolve doesn't just solve problems faster, it changes how we think about solving problems. It doesn't rely on theories. It doesn't need to understand the math in a human sense. It finds what works and refines it until nothing better remains. That's the scary part and the exciting part, because we're no longer handcrafting algorithms. We're collaborating with machines that discover them on their own, machines that work at speeds we can't match, with creativity that doesn't come from inspiration, but from brute force evolution and tireless testing. Coming up next, the big question: what does this mean for human innovation? And what happens when the smartest algorithms on Earth are no longer built by us? The quiet shift no one's ready for? Alpha Evolve doesn't argue, it doesn't explain itself, it doesn't ask for credit, it just works in silence. It writes code faster than we can, finds optimizations we'd never spot, and solves problems that stumped the best minds for generations. It's not mimicking human programmers, it's replacing them in certain domains. Not by being more creative, but by being more relentless. And here's the part that sticks. It's not even close to finished. As language models evolve, so does Alpha evolve. Every improvement in Gemini means sharper instincts, faster iteration, and even better solutions. This isn't static tech, it's growing, shifting, learning how to evolve better. We used to think the job of designing algorithms, the very logic that runs our world, was safe, that it required deep understanding, years of study, flashes of inspiration. But what happens when machines no longer need inspiration because they've discovered a better system? What happens when the smartest algorithms on the planet aren't taught or written, but evolved in silence? That's not science fiction anymore, that's where we are. So the next time you use an app, run a search, or interact with AI, just know there might be something behind the scenes making it all faster, cheaper, smarter, and that something may not be human. If you found this breakdown eye-opening, let us know in the comments. What excites you about Alpha Evolve? What scares you? Don't forget to like the video, subscribe for more deep dives, and we'll catch you in the next one. So, take a deep breath, check out the links in the description, and see you next time.